We can take what currently other people consider as a waste, CO2, and utilize that to produce more domestic energy here at home in order to lessen our dependence on foreign sources of oil. So we get benefits of producing more domestic energy as well as the environmental benefits of permanently sequestering the CO2 in that process.
Southeast Regional Carbon Sequestration Partnership is one of 7 partnerships that were established by the U.S. Department of Energy to look at the potential for using geologic storage to reduce greenhouse gases.
Sequestration's high value to us is that we could use it now. It's ready to go. We have decades of experience placing CO2 underground and also how to monitor a site to show that it's performing correctly.
Injecting large volumes of CO2 underground is not a trivial activity, and as such, NRDC has spent a good number of years, coming up to 12 years now, into researching exactly how this works. Can it be safe? Is it effective? What are the possible side effects?
Our research is how to effectively and efficiently determine that the CO2 that's placed underground is remaining underground. And because it's remaining underground, there's no other unexpected, unpredicted harmful effects.
Having looked very carefully at the available evidence and studies by the expert scientists, we do believe that this can be done safely and effectively. And in fact, it has been happening for a number of years now, and enhanced oil recovery is a practice that's been taking place in the country since the early 1970s.
This offers really the only practical solution that we know of, where we can take carbon dioxide and safely sequester it in underground reservoirs, where we know that, it will be trapped, because obviously the oil has been trapped there for millions of years before it.
One of the things that people don't understand about storage underground is how far underground the storage is occurring. The depths that are usually used are more than a mile, often close to 2 miles, and that distance is through solid rock.
All the sites that are selected for CO2 sequestration are well below the depth of groundwater. They're separated from groundwater by regionally significant caps, quite often 2 different cap rocks to hold the CO2 in place.
And the world's scientists have converged in their views in saying that there is very little, if any, risk of releases of that CO2 if it's injected in good candidate reservoirs.
If you're going to continue to utilize coal, which is an abundant resource in the United States, and meet policy goals that are being set for carbon reduction, you need to be able to get the CO2 out of the atmosphere.
We can take that CO2 and not emit it into the atmosphere, use that within CO2 Enhanced Oil Recovery, produce more oil, i.e. more domestic energy in the U.S., while also sequestering that same CO2 in the ground permanently and not releasing it to the atmosphere. So basically we can do 2 things. We can obviously produce more domestic energy, which we all agree we need to produce more of, and secondly, we actually sequester more CO2 than what that oil eventually will give up.